some simple risk assessments, because it is when you are doing that, quite simple ones, you really get what I'm saying today. Unless you already did quite some of these works. And I would prefer that we discuss and you ask me questions and I don't get through the whole presentation. I think that is better than me just having a monologue here. So please stop me and ask me questions if things are not clear or you would like to discuss things. And yeah, so I think I start. Could replace So the content of the first work is first a step on exposure. And you remembered already yesterday that we talked about risk assessments. The hazard is kind of constant. It is the exposure that varies a lot. And it's the tricky part to assess. But I will talk a little bit what we are doing, and I will also talk a little bit about what is in development. Because the environment is changing. I will give you also a lot of information what has been ongoing within European Union. We have now been through a big review, and during that review we did a lot of risk assessments and drafted and produced reports. So now these reports are available for you online. However, it's up to you how to use them. And that is a tricky part, and we will for sure discuss this. And there is also works going on with the FAO. Does anybody know about the toolbox? It's a toolbox that is created by WHO, FAO, UN, OECD. You didn't hear about it. It's meant to be a tool for people globally. There are parts of it already available. And I will tell you a little bit what's ongoing with FAO. Especially we have started with, for example, operator exposure modeling, and how you can take works being done in one country and you can perhaps extrapolate to your country. That's the idea. And then we will look together into some databases. We will see, go online, and I think we have a little until the afternoon website. Yeah. That's the idea for today. I will do the same for the environment, and then I put it together in the part called risk management. Whether
What's the arrow? You pushing the arrow?
Oh, you know what?
No,
Support you on Skype, so the Skype's come over or above it.
It's the right one.
the right one. Okay, let's. We will see. Otherwise, I understand. So, if we talk about exposure pathway, do you see this, or you see it on your documents? It's not so clear. You know, there are different pathways. You are exposed by different pathways as human beings. This is quite general. It's also relevant not only for pesticides, also for all chemicals. Consumer products, from the environment, from the air, from the water, and also, of course, where you work, occupational environment, workplaces. And you see, when it comes to your body, it could be oral, you eat and drink, you inhale it from the air, or it gets on your skin. And those parts are taken into account when doing the exposure calculations.
I'll ask something because this is a test question that you'll have at some stage. But we have 4 avenues for being exposed. I just want to know if the test uses the 4th one. Anyone think of the 4th one that's missing? No, oral's ingestion. Oral's the same as ingestion. Anyone think of the 4th one that's missing? 4th way that you can get pesticides into your body? I'm looking at you. Your eyes. So ocular is the 4th way. And what I wanted to ask is, do they use ocular for the risk assessments?
No.
Which is interesting. But that is when you have a test question, what are the 4 ways? That is one of the 4th ways. So it's interesting that the risk assessments aren't actually using or looking at eye exposure or ocular exposure.
This is a very good comment also to explain a little bit more. You come from the scientific part of the world, taking everything into account scientifically. I come from the authorities. I'm very practical. I take the tools I have. And that's also you should bear in mind that there are differences when we are discussing these things. And what I can add already now, it is when you are doing these risk assessments, and pesticides are toxic, and some of them very toxic. So you come to the borders, whatever assessment you do, you still have a problem, it's not safe. So you are pushing the whole system, the whole development of carry out risk assessments, also for the science, because they had to figure out how to further develop the methodology. And that is even more true for the environmental part. And then you might, as I can also already now say, in Europe we have gone so far on that route, especially for the environment. So now we see it has become so complicated. So we say, this is mad. Let's go back to hazard, because the risk, it doesn't help, because you do the risk assessment for a very special spot, more or less. It's not general anymore. But we will come back to that. But this is clear to you. I think it's
I had to, she couldn't see the slides, so I had to, okay, try it now. Not, yeah, there you go.
And a special emphasis on children. Why are we so concerned about children and the exposure of children? They are not supposed to be exposed in working places. But I saw a photo from yesterday of a young boy with a backpack sprayer. He looked like 14 or something.
It's actually a girl.
Was it a girl? Anyhow, a young person. It's no big difference at that stage. That's not good at all. So if you would like to reduce risks in a rapid way, you say no children in the fields. Then you reduce a lot of risks. But why are we so concerned? It is because the first thing is rapid metabolism. So the metabolism is very high, their bodies are very small, so when they are exposed, it's a higher concentration to their bodies. They are immature, their systems are still developing, and this you should bear in mind when we talk about endocrine disrupting substances. The body is still developing until you are 25 actually. And the behavior, of course, these guys. I mean, you say you treat the carpet and then a baby is crawling on that one. and they put things in their mouths and so. So it's a different exposure to their bodies as well.
So just to comment, we say that children are not little adults, and that's very important to remember in terms of risk assessment. And at some stage you'll hear about in the US how they do specifically standards and regulations for children because of their exposure risks are so problematic. In terms of also the long-term effects that they'll have from pesticides.
They do an extra assessment factor, don't they?
Yeah, so 10 times.
Yes.
Yeah, for children. So they take the data and then they add a 10 times factor on it to say that for children, that their exposure, in order to reduce their exposure, they add a factor of 10 on the final risk assessment calculation.
Okay, how to then calculate the exposure? What we often do, we have now exposure models, and we will look into that tomorrow. There are exposure models for operators, for workers going into the fields or pick apples or go into greenhouses and so on. And also what we call bystanders. If people are living nearby a field or you are passing by, or if you treat schoolyards or whatever, that's disappearing more or less, but it might happen. There is nowadays big databases available. And these databases are built on measured data. So it's mainly industry has been out and measuring the concentrations, often on your skin. That's the measurements, with and without like gloves and masks and so on. So it's a real database behind. And then we use that to calculate new dose rates, how many times you are treating the crop and so on. These are available for us. And already now, I also would like again to bring up precautionary principle, because what we are trying to do is to prevent that people have too much exposure that will have problems. We don't wait until we see the problems. So therefore we use modeling to try to estimate could it be safe or not. And this is really important to know. What you then could do, you can go out and monitor, of course. And you monitor workers. And you can even more, you can look into the blood samples. And you will see that tomorrow, because we will show you a film where they are monitoring chemicals in the body. But then it's too late. And then I come back again to policy issues. If you are very ambitious and you say we should protect our population, high level of protection, you shouldn't find those substances in the body. Those activities should also be carried out to control whether the modeling and the assessments are okay. That's the view, at least within Europe. There might be other views around the world, but that's how we see it. And that's why precaution is so important. So you see the difference. Yes?
So there was the issue for personal monitoring. And
So
also-
I think you must,
Yeah, you
No,
said,
for-
and also
I'm
say
saying that
remember.
I never had clear the difference between personal monitoring and environmental.
pesticide.
No, personal monitoring
Yeah.
and biomonitoring. I never had clear.
The difference. Biomonitoring, as I understand, it is when you go out, you take samples from people's bodies, like blood samples and so on. I'm not the expert, I must say, I'm not the expert in this area. I'm the expert in environmental risk assessment, but that's how I understand. Biomonitoring, you can also follow enzyme activities and these things within human bodies. And the other is more when you monitor what's on your body.
So the biomonitoring, the biomarkers are generally your blood, urine. Blood and urine are the most common, and then sometimes saliva, and now more recently they're doing hair samples. But the problem with biomonitoring is it depends on the metabolite of the pesticide, whether you can actually find it, and it then depends on the lab. So, for example, the work I do on herbicides, no labs in South Africa are working on metabolites that are found in herbicides. So you would have to send your blood or urine samples over to the US to find a lab that could analyze it. And that's problematic. So, and the other thing is that a lot of workers don't like giving blood because they feel then that this insecurity with their employment, that their employer might find out that they're HIV positive. So biomonitoring is expensive and it's difficult.
Okay, exposure models. I still let this list stay. There are several models around the world, and they are listed here for consumers and for operators, workers, and bystanders. They have all the weakness and strengths, and it is just to list them for you, because when you go into existing reports, you find then references to special models. What is new and that I am very happy about is a new model that came out last year from EFSA. You know EFSA, European Food Safety Agency. It's the agency that's supporting the European Commission on these issues. And it's in that model they have updated the databases behind the models. You have new good data behind the model that you are carrying out. And it's, I will show later, it's a simple Excel sheet. It's easy to use. I just tested it, and we can test it together tomorrow. But for sure you must know what you are doing. It shouldn't be a black box that you put some data in and something comes out. Together with that Excel sheet, you get not too big guidance document, also explaining that model and what's behind. And as far as I have studied it, I think it's a good tool. But then again, for you, then we can also discuss perhaps further today or tomorrow, how can you apply it to your countries, for your operators and so on. That's a big question. So in future, I guess you perhaps, if you start working with this modeling, you can use that model and adapt it to your environment. And that is also going to be used, as I said, the FAO is going to provide countries with a useful tool, and that model is in it. But we are still discussing how can we also give guidance on how people can adapt it to their countries. Could you think of what could be the differences? It's perhaps difficult. We can come back to that question. I will describe a little bit more how it works. I do that first, and then we can discuss how people are working. The working situation differs between countries. Okay, let's have a look also a bit about hazard. Are you familiar with toxicology? Perhaps I should also illustrate by, we have a pen for this. Oh, it's here.
Is it one there? Do you want one?
No, it's okay. What is common for ecotoxicology and toxicology is this one. And you have it in the handouts. You put the dose and you put the effect. Like this. And you see this case, these are the same. Often you test a lot of long concentrations. You have a test animal, or you have a fish, or you have the algae, or you have a mouse or a rat, whatever you are testing. And nothing, and you have of course a control that you could have to. Nothing happens here, low dose, and somewhere here you get effects like that. This point is very interesting because when we talk about low effect level, and you are aiming at this point, you would like to stay here, and you are testing a lot of species. You know, species are different. The sensitivity to species differs, of course. There is also difference within species. And again, if you look at human beings, children, women, men, elderly, and so on. But anyhow, we are aiming for an exposure sooner or later below that level. We don't want to see the effects coming and whatever we measure here. There are some cases, and that is illustrated here. You see non-threshold. You can't find this. It goes, as soon as you are exposed, you get an effect, something like that. Now we start to worry.
So the threshold is not the point of the top.
No, it's here. I mean, you have, dose is increasing. It's 10, it's 100.
So can I,
Yes,
if we were testing a chemical,
yeah,
let's say a rat poison,
yeah.
where there's, at the low dose where there's no effect, that's not useful. You need to have it where, are we looking at this from that point of view or from the personal point of view?
But you can say both in that case. If you are out to look for efficacy,
Yes.
you would like to fight the rats or kill them. Then perhaps you are out for, we often talk about LD50 or EC50 perhaps.
EC stands for?
Effect concentration that is relevant for fish when you have an exposure in water. Yeah, so now we are talking about two things. The first question you asked was efficacy. You would like to fight the rats with mice. Then you should show the authority that you are coming now with a new product, is effective. And you show data that at this dose you kill half of the rats. That's another story, but you must show that as well. But what I'm talking about here is to protect other animals, but the rat is also instead of human beings. Because we don't test humans, we test animals. And then it's the other way around. We would like to stay here. This is very important that you get this, because it's the philosophy behind what we then discuss. And again, if we have this situation, we really worry. We can't find that threshold. And that is true for substances that are mutagenic. You know, one hit and you might get cancer. And that everybody agreed. Those substances should go. They shouldn't be used. I will come back to this later on when we talk about endocrine disruptors. But I hope you get this.
What you call that where there's no threshold?
Yeah,
So you
no
have
threshold. It's, yeah. There are some well-known chemicals. It's similar to what do you say in English? Radiation, when you're exposed to that. I mean, if you get a hit in your genes or so, it could cause you cancer. Is it difficult for her to be?
The thing is, we still have radiation that we use for X-rays.
Yeah.
It has a benefit. It has a side effect, but it
Yeah,
still has a benefit, doesn't
yeah,
it?
yeah.
So it's kind of,
Yeah, that is often the case. It's clear? I think you see this, this is a photo, this is my colleague testing, we discussed this yesterday, these protective equipment. And it's very good just to see, keep that in mind when we talk about risk assessments, just to illustrate that. Also, I kept this one just to explain you that we are a little bit stupid in Europe. Here we talk about pesticides whatsoever. In Europe we talk about plant protection products and biocides. And why I'm raising that here, it is again when you go into to internet and look for reports. I want you to understand that we have two systems, very similar but different. During this week, I will ignore the biocides because I want to make, it's better I make clear the system for plant protection products, agriculture parts, and then we can add the others to it. If I start to explain you also the other system, it's confusing. It's sometimes still confusing for me, even though I have been working with it for 20 years. But again, agro-pesticides, we say, you know these ones, herbicides, insecticides, and fungicides used on plants and also for storage. The other ones, like anti-fouling products, paints on the ships. We talked about yesterday, mosquito repellent products, wood preservatives, household pesticides. These are very important in your case, but yeah, I put it aside to simplify things for the moment at least. And this is just, referring to the regulations we have. We will have a look at those regulations later on. And you see they are quite new. The one for agri is from, it came into force 2011, it's brand new, you could say. And the other one, even younger, 2013. And again, the reports you find online, they are not so much yet applicable to this system because they are applicable to the system we had before. Okay, I kept this. Exposure of biocides. The biocides are divided into 33 use groups. And why did we do that? Again, it's related to exposure. And exposure could differ a lot. You use a product for wood preservatives. Often that is industrial treatments, quite often, or your paint. Indoor household use is a quite different exposure. So therefore, the politicians decided to do this. It's very complex because, for example, insecticides could appear several times in different groups. And then you do a new risk assessment for that type of exposure. This is just an example of anti-fouling application. A few words about data requirements, and that I think we will come back to tomorrow on Thursday. And I will show you the lists of data requirements we ask for. I will show you a photo later on today. But in principle, the system is that when you apply for authorization, approval, we say nowadays, for your active substance in European Union, it's a two-step procedure. First, you apply for the active substance, but for the authorities to be able to assess that substance, you must also submit what we call intended uses. And this is really pragmatic, because we started off trying to assess all uses. Nowadays we are 28 countries in European Union. And you have, if you look from north, from Sweden to Spain, in Spain they have much more need for insecticides than we have in Sweden. If you look from the west to the east, in Ireland and UK you need much more fungicides than in Hungary and eastern part of Europe. So that was impossible to try to catch all these uses in countries. And it was a long debate. And it ended with the agreement that, okay, the industry should submit an intended uses, because then we assess that together, and that is what you find in the reports that I will talk more about soon. So that we could together say whether there is an acceptable use within the European Union. And if it is so, then the next step is that industry goes to countries and apply for their products. So it's two steps. And again, that is also why you can take a first step of assessment and take to South Africa or Kenya or Zambia, and then you adjust for the uses and need in your country. That is, in theory, you can do that at least. And then you must also, as we said, rodenticides, you must also submit efficacy studies to show that your product is efficacious. That must be shown. And then toxicology. And when we talk about products, we also need, often we get data on dermal absorption, actual data on that product. Then we are at the product level. And please stop me, because I know I'm throwing things into new terms and so on. So it's very much for you to digest. Going back to exposure then, the most risky event during the work, during a day for spraying, that is mixing and loading. When you take the product, you mix it with water, and you put it on the back or you put it on the tractor and you start spraying. When the experts have done these measurements, they have identified that as the most risky part in Europe and US. I don't know whether you can see other stages in your countries. And the model also, then we have the model, so there are, the model is now covering that stage. Also when spraying, you spray with a backpacker. I hope you don't go like that, I don't know. I'm not the expert of that. And also if you sit in the tractor. And then you have a problem, you must go out and check your muscles and so, and then go back. it's covered by measured data. And then we have bystanders and resident exposure. Data for the exposure of these are taken from spray drift. These are also measurements. Those spray drift data we also use for doing risk assessment for the environment. Actual measurements, how many percentage are going off the fuel. And of course, consumer exposure, that's the residues in food measurements. And that you do also in South Africa, for example.
For export,
Only export.
any export. Right? Yeah. We don't have the money or the labs to do residue testing for local market food. So what happens, we do it for export, because that's where the money is as well. And it has happened that if the residue limits are too high, export food, that it then gets put on the local market. It happens in Kenya as well. Yeah. It's a pretty common.
I mean, what I can, again, Chem is not the main authority in Sweden, it's not a food administration board, but we cooperate tightly. And what they are saying, of course, we are not out sampling all but you take samples. And we do a lot of imports, I mean, in European Union, and there is sampling also at the borders. I mean, you grab samples, and then if you find exceedance, then you concentrate more on that type of crops. I remember years ago, we had problems with pepper from Spain. So then they focused on that import to check whether it was okay. And the Spanish colleagues, they said, these are the Swedish fields in Spain. So it's the same. But still, it's very important you have some kind of control. And when industry is applying for authorization, they also give in data from residue trials. And then it is that data you use for risk assessment. And just to add to this, this is also sometimes discussed. Exposure is not calculated for bad behavior or accidents. If you go with your tractor into a ditch, everything goes into the water. That is not calculated. Or if you are drinking pesticides or something. You don't take that into account doing risk assessments.
And added to that is also if you're wearing the wrong PPE. So risk assessments aren't conducted on wearing PPE that's not required or not recommended. So in South Africa, a lot of the farm workers will wear a dust mask rather than a respirator, but the risk assessments aren't done on the exposures of wearing a dust mask, which would be much higher.
This is a common situation in Sweden. I can say I never saw somebody with a backpack. In Swedish, we have big fields, and that they are tractor mounted. But that differs in Europe. I mean, if you go to grain fields and vegetables, also one exception I think is within glass houses. But I think they are more and more moving to automatic spraying of treatment in glass houses. This is from Asia. This is very, it's more common also in Africa, I think, than Europe. But I have seen really bad photos from Asia. That is a scary one. People are going on a row like this in a crop. I don't know what crop it is. It's high like that. and they are spraying in front of them like this, and they are walking into what they just sprayed, and they just have something, a cloth or something, because they don't know. Again, awareness raising could also, for sure, reduce unnecessary risks. You get advice how you apply the products. But going in front, spraying in front of you and then go into it, that's very bad. Okay. Well, you already comment on this one, and I heard another comment, and that was, am I supposed to eat that thing that they are spraying, needing that equipment? I think it's salad or something, and you can really ask that.
So if you're eating something that it requires that amount of equipment, you need to ask that question.
But then you have a long period between the treatment and the harvesting. That's what we work with. But you can ask your parents. Okay, what kind of information do you need to do this type of risk assessment? We talk about gap table. Heard about that? Good agriculture practice. And that is set by the applicant, the one who is applying for authorization. That person or that company is saying, I apply for this use, this dose rate that many times for this crop, and with a spray-free period between last treatment and harvest. And that is the use that is assessed. So then again, if you don't look so carefully into that gap, and you do other things, then the risk assessment is not applicable anymore. But that is also, it's important because that is what the industry they support it. And that is what we assess. Okay, now we can discuss again. We do this assessment stepwise. We do it for health and we do it also for the environment. We start off with a realistic worst case scenario, we can say. So operator exposure is, the first step is to calculate the exposure and then the risk without any protective equipment. If that is okay, it happens a few times. I asked colleagues, I didn't expect that, but could happen depending on the product. Then it's okay, you don't do more. It's a simple calculation, it's okay. Don't worry. But often then, okay, I'm going too far here, I see. Okay, I come back to that exposure assessment. Let's discuss a little bit a very important acceptable overexposure level. How do we calculate that? We look into the database for toxicology. There is a lot of data. I will show you the photo later on. It's 10 meters of folders. And then different types of tests. And we can have a look later on the data requirements. I don't know what kind of data requirements there are in your countries yet. But I'm talking about the agreed data requirements that has been agreed within OECD. So Europe is using it, US is using it, Australia, New Zealand, I don't know, but many countries are using these agreed data requirements. And the tests are also carried out according to guidance documents that OECD has agreed upon, and good laboratory practice. So it's really standardized. So you have a lot of studies. And a toxicologist, that kind of expert, is now looking into all this data. You look into that data package, all of it, and then you select a no A or EL. What I'm talking about here. You will have a lot of these data from different tests. And then you select the lowest relevant one. There is a big guidance document how to establish this very important value that is available, but I will not go into those details. But you should know that behind such this value, and these values you find in the reports I'm talking about. And I think that you can use those values for your risk assessments, but for you, you must figure out how to do the exposure calculations. But these AOEL, they are global for all human beings, I would say. Not children, because we don't expect children to become operators. So if you foresee children to work as operators, you must take that into account as well. When you establish this, you work with safety factors. It's animal testing, so you must take into account the variety within the species. A rat species, group of rats, group of humans, rabbits, whatever. And now we come to politics again. What we say when we establish such a factor, we say it should be at least 100. From that, we add a factor of 100, at least. You heard about US EPA, they add an extra 10. I don't know if that is related to residues in food or so, because you don't expect children to work, do you? I don't know. Residues in food, yeah. Yeah. So it's a variation within species and also between species. You get that thinking? Yes.
Sorry.
Yeah?
So then if your acceptable level of operating exposure was 10 milligrams per kg
Yeah.
per day, the NOAL would be 0.1. So you divide 10 by the 100.
Yeah. And the 10, you pick from
The lowest.
database. So you get, but sometimes when you do animal testing, I'm not the expert, but I have understood, you pick concentrations. And when you do these rat and mouse, I think, studies, sometimes you do dog, it's a long time, it should represent the whole life time of an organism, we say, so an animal or a human beings. 2 years for rat, for example. Even though they try to figure out the concentrations they are testing, it's very expensive, intensive tests. They might not be that lucky that they find exactly here. So if you are uncertain of this one, you might add an extra factor. What is happening is that the tox experts, they sit together, often it comes out the draft report from one country, they sit together, don't agree, discuss and argue, and finally they agree. and that is based on science, but also policy comes in. And you might see lower value than 100. You might see lower, for example, from US, I think, because we don't accept tests on humans in Europe. That is for ethical reasons. There are such tests around, especially for organophosphates, where you can take blood samples and measure the enzyme activity. And then, but we don't accept it because we saw that the people tested were, they could be very poor students, could be prisoners, and other categories of people. So it's not accepted in Europe. It's in the legislation itself. And it is in the legislation itself, this 100. But it could be bigger. Sometimes you could see a factor of 1,000. So you see the policy comes in also when you do risk assessment. Okay. But it's clear, I mean, I really emphasize the AOEL, I mean, and I also say you find it on the web. So you don't have to evaluate and calculate and discuss those values, unless you have another opinion. Of course, you are free to have that. These reports, you will look into them, they look like this, not too big, compared to other reports. And you find those very, we call them endpoints, both for health and environment. You find them, this is for the active substance, dichlorobos, it's an organic phosphate. We'll come back to that, but I think it's useful, that one. How much time? Okay, going back to the risk assessment, what I wanted to emphasize here, it is, I already started to talk about it, no protection, you put on gloves, and you calculate again, is it acceptable now? No, it's not. You put on overall, coverall, or whatever you say. You recalculate, it's not okay. And then the final step is protective mask. So you do it stepwise. And you do it for mixing and loading, as I said, because that is a critical stage. But also, you measure, of course, during the application procedure. And I know we had serious discussions in EU, and I know I was very difficult sometimes, because the discussion went crazy, I think. There are some substances so very toxic, so then the expert said, okay, you need to have gloves and boots and coverall and mask, sit in the tractor and shut the door. But then you say they are not exposed. But you see, and that you can see traces of that in those reports. And you can tell me what is relevant for your country and your operators.
So if I can just comment on this. Now, there's a lot of subtle issues here, and I'm not sure you're picking them all up. So for example, Lillian made the comment that for mixing and loading is often the highest exposure. And this is what you will hear people say here in Africa and in other lower middle income countries, that's where the highest risk is in the mixing and loading, which is actually not the case in our countries, because our operators don't have those machines that you saw the photograph of. So these big tractors with enclosed cabs, which have ventilation. And predominantly that's the assumption. The assumption is they're not doing backpack spraying. They don't have backpack sprayers. So the assumption is the exposure for the operator is actually quite low because they're in these encased vehicles. So you need to remember that the data and the information that's coming from the transnational company, from the parent company, or from an authority that is not in a lower middle income country is already taking assumptions. They already have risk assumptions, as we spoke about yesterday. So they're assuming that the operators aren't exposed, whereas it's completely different. We've got children. That picture of that girl with the backpack sprayer was in South Africa, in KwaZulu-Natal, and that wasn't taken too long ago. And so we actually have children who are wearing backpack sprayers, who've got no clothes, no protective equipment. So then you have to think about this data that's saying what is the risk, and looking at no protection, gloves, overall protective mask. Well, we're at the no protection stage. And the other thing that you have to take into account is in America they have 9 different gloves they recommend on the label depending on the active ingredient of the chemical. We use one type of glove for protecting. So these are all the issues that you need to take into account when you think about risk assessments and using this kind of data. You need to critically evaluate it and saying, what are they actually using? What is the equipment that they're assuming people are having access to? So you need to unpack what's behind the data. We get caught up and lost in this complicated risk assessment, which it is. It's complicated. Then we forget the context within which we're using it.
What could be interesting during your, I mean, you will come back to this during the course more. Now I'm kind of surfing. I mean, I don't get headache if you don't follow everything I'm talking about, because you will return to this and discuss much more in detail. What could be interesting, Andrea, is, as I said, that within FAU there is a work ongoing to try to guide better and adapt, also guide to what you are saying, adapting this type of data and reports to relevant scenarios in other countries. And what we might be able to do is, because it is to test that guidance, is draft. But when you are working, we can talk with Mark and colleagues whether we can test it with you, because you can give very, very valuable input to such a guidance from your experience. That will come during, so is that during toxicology and
Oh, you mean the course?
Yeah.
Yeah, that's coming in April.
no, but anyhow, I mean, Andrea, yes, but and that was my thought at least. And I say again, you have, if you have a risk assessment being carried out, saying, as I described you, that in Europe you need to have full protection, sit in the tractor, shut the doors, then you are okay. If you see such risk assessment in the report, you can start to reflect, okay, what's the risk in my country, without calculating so much. It's more just, yeah. Still, it could be useful information for you. And I mean, I have no solution for how to do this. One way you describe your current situation, as you say, a young girl with a backpacker. I mean, you don't have to calculate the risk. You can say she shouldn't walk there in the field with that one.
So the issue is that you can't control human behavior, but you can control at the regulatory level. And that's what we're going to talk a little bit more about later, is that when you're doing risk management, we often try to control the most difficult denominator, which is human behavior. And then we say people are ignorant, or they're misusing, or they're stupid because they're not wearing their PPE, or they let a child use a backpack sprayer. But the reality is that we need to take into account what the situations are and regulate for that. So we have to make decisions of what kind of pesticides we are regulating. Are they highly hazardous? And being realistic that we're not going to be able to control people wearing protective equipment or people using children. So it's flipping the way that we are doing things on the head. Changing human behavior is the most difficult thing to do. How many of you wear seatbelts when you drive? Does everyone wear their seatbelt when they drive? No, you in the room here, but in general, does the general population know? If we know the risks of not wearing, there's enough information out there about it, but not everyone wears their seatbelt. So again, human behavior is the most difficult. It's the fine.
Okay. Okay, about a few words, I'm coming to the end of this one. I mean, a few words about the criteria and decision making. For the health, it's quite simple. It's more sense. Because you calculate AOEL. You have that inherent property. And then you calculate, sorry, yes?
Sorry, are we saying that this model cannot work here?
You tell me.
Because the general assessment is, because like what Andrea was saying, there are so many factors that are not, that can't apply to the model. For example, when the model, like you were saying, you have to use a tractor, something like a closed one, but here we use backpacks, where if ever the backpack has got a hole, the chemical can drift into the safety, the PPs, and then it gets into the skin. So what I'm thinking is this model cannot apply. That's my opinion.
Yes. When I gave these examples, I gave the bad ones. As I said, if we go back to the modeling calculations, let's say that when you calculate this, there are cases where it's fine when you compare the exposure to AOEL and you are below 100%. There are such cases, there are such products, actually. And that is starting to become interesting for you also. That it could be so that it's a very smart product that minimize also the exposure. There are such cases, but in most of the cases, at least you need gloves to protect yourself, or even more. But the industry is also working on the products to make them smarter, more clever. So people are, I mean, you say dust, dust, you say that, the powder, yeah, the powder. They are more or less going out from our market because they are interested when you are handling those.
So, you mean products that are powders?
Yes,
Yeah.
yeah.
But then I'll put them in the powder into a liquid form.
Yes, but this
Yeah,
handling, so industry is working on that to create more, to produce, okay, often they become more expensive, but at least to reduce the risk. There are coming more and more interesting products, and I will show you when we talk about comparative assessment. You can work on that level also. Yes.
Like when you talk about gloves, I think generally when you talk about gloves to the farmers here, the only thing that there's only one type of gloves, which is latex gloves. I've seen it during the Ebola virus, I mean the controls at the borders. When they said wear gloves, everybody was wearing a latex glove. But then they then said latex gloves cannot protect us from the virus. There's a specialized kind of gloves. So I think when you talk about putting gloves, I think they have to specify. Because generally when we talk of gloves, everybody thinks of latex gloves. And you will see them wearing latex gloves, but latex gloves cannot protect us against all other pesticides. I mean,
Yeah.
I think the thing is, if we take the hazard, we've been talking about the hazard. We've already taken the NOAA out, the normally acceptable level, and we've divided it already by 100. So we're making that product already relatively safe. So the risk now of how people are using it is, there's still a safety margin. You know, just as soon as we say something's a pesticide, oh, you can't touch it or whatever, I think now we start overreacting to the thing. We've already got safety factors built in, but if people start doing silly things, it still doesn't matter. It's still relatively safe. Are you getting my point? You know, just because it's, you know, because we've got all classes of pesticides and all different things, but the ones that we're making available to the most people have already got safety factors built in right at the beginning. And we're just trying to see down the line how we can make it, keep it safe. And at what point is it going to be a problem, actually? I think when we see some data figures and numbers, we can say, okay, look, if a guy's got a product, he's got 100 milligrams of this product, the active ingredient is 1%, okay? He would need to bath in 10 liters before it would start having any effect anyway. So I think it's getting realistic.
Yeah, it depends on, I can give a good example of handling the risks by developing the products. And that is, if we take rodenticides and warfarin and these, they are really acute toxic, really, because they should kill the rats. And the rats shouldn't, they are clever animals, they shouldn't understand what they are eating, killing them, so you have that. But and that, when we started the review in Europe, there were available those tracking powder, they said. It's gone. What you can use now are kind of wax blocks, and I don't know whether you have it. Yeah. And we have restricted even more in Europe, so it's not anybody anywhere who can do it. We also put them into kind of a box, so that's so you also prevent secondary poisoning or burns and so on. But that is one example when you work with you develop the products so they become quite safe, you could say. That is one good example. But yeah.
Just like to add on what you're saying about the rodenticides. We find in Kenya, rodenticides are very common because people have rats and everything. So it's also easy to have it taken quick by children and human beings, and adults, sorry. But you find the effect of one of that is not enough to have any effect on the adults. But if you take more, we tell people, if you want to really kill yourself with a rodenticide, you need to buy a pack of like 10 or 100 of them. Then it should have an effect. But only one might not have, and that's why it's safe maybe to use around the house. That's what you
But if we use that exact example of warfarin, I use technical warfarin to create rat poison. Okay, I'm using a very highly toxic chemical, and then I'm personally diluting it down. That poison, okay, if you go to the hospital here and you need surgery, they give it to you as medicine. Okay,
Yes.
so it's the concentration. Exactly what you're saying. If someone eats one tablet of rat poison, it's actually good for them. You know?
Could be. It depends on the.
Yes.
So let's be clear
No,
about
but
that.
I'm using
So-
warfarin. I'm using warfarin
Yeah,
as
yeah,
an exact
yes.
example. It's a medicine on one side,
Yes.
and at a certain concentration, it's poisonous on the other side. So I think that's the point we've got to be realistically. You know, it's.
So the issue is, and this is what you're hitting up against, is it's again going back to the contextual issue. So how do you balance what's actually realistically happening with the chemicals, with the data? So, we talk about safe and we talk about acceptable risk, but then you need to look at the parameters within which that safety has been determined. So for example, let's go back to the the rat pellets. So rotifucum is a very popular one that's used here. Now, they've banned it in the US, because of the acute toxicity of it, and kids are eating it. Now in South Africa, here at the local Children's Red Cross Hospital, which is just down the road, it is so routine, kids coming in with blue urine. The tablets are blue, that they don't even admit them to the hospital. They're treated as an outpatient, given a vitamin K injection, and they go. It is so common. And why was it common? Well, you step back a bit. The Department of Health was handing out free packets of these tablets in the townships because of the rat problems that were happening there. And so what has happened is the Department of Health then worked with the Department of Agriculture, realizing that they weren't supposed to be repackaging these things, and they're now trying to go more with the vape blocks. But the problem is, we talk about the acute toxicity. You'd have to eat a whole lot to die. And that's what we keep focusing on is, nobody's dying, you can drink the stuff, but we don't look at the chronic effects. So what is the effect of the children who are coming in with the blue urine 20 years from now? What is the effect 10 years from now? We don't know. We're not doing risk assessments on chronic. Well,
Yes.
we're doing risk assessments on some. So now you've got children who are HIV positive. We've got a TB epidemic. They might have measles, and they've eaten this rat pellet. But we don't know. There's uncertainty. So the question is, how do you regulate for that uncertainty? Instead of saying a product is safe, you look at the contextual issues. So you change. You remove the pellets. You remove growth cocoon. You use the vape blocks. You change. So that's the kind of approach that we need to think about in our context. Is that some of the products we need to either change the formulation or we need to actually take them off the market because of how they're being handled.
Yes, but the chance of them getting bubonic plague from the rats and the fleas is far greater if we don't have the rat poison. So it's how many have died from that poisoning? Rat
I'm not talking about that though. I'm talking about chronic effects.
Chronic effects.
And accumulation.
Yes, but yeah,
And the accumulation also.
Yeah.
Remember, these chemicals will be accumulating in your
some of
body.
them yes, but some of them don't. They break down. So it's
Yeah, but you really, on a layman cannot distinguish those that accumulate and those that doesn't accumulate. So we just basically think that everything accumulates.
yes, but we have a problem. Okay, so there's a problem we're trying to solve, which is the rats. You know, so
There are natural methods of solving that. You can just buy a cat.
That's a funny solution, but that's exactly the point Mark was making yesterday.
Yeah.
And this is the challenge that you need to think about as a pesticide risk manager, that we're not always looking for chemical solutions. And if the context is such that it's difficult, cats have their own issues and their own problems. They're not accepted in the townships in South Africa. But in the study that we did, we distributed 400 rat traps, and people actually liked them. But we weren't using the standard rat traps that you can buy in Pick n Pay. We had high-tech ones that we were using, so they were very efficient. So again, it's unpacking the contextual situation and looking what are your options and range of solutions. And yes, maybe at some cases, like at the supermarkets, they use these baby blocks. You see them all around Pick n Pay, the bait stations, and that's fine. Exactly. And rat traps might be a bit inappropriate as well, possibly. So it's always assessing the context and the exposure and the risk and the hazard, and putting those into the equation to come up with your best management strategy.
I just want to add on that we mostly look at the acute effects most of the time. That's why we'll continue using the right poison in the wrong way, because you're not seeing any immediate effect. But the 10 years or the 50 years from now, that's when, because when we talk to people who use pesticides and you tell them you need to protect yourself, you need to use it in the right way, they always say, I've used this for 10 years and there's nothing wrong with me, but they don't know the chronic effect, because you always look at the acute.
And just to add to that, so that to do a good epidemiology study on the chronic long-term health effects of pesticides would take 40 years. And as I mentioned yesterday, there isn't funding available. Pesticides is not a sexy topic. It's hard for researchers to get funding. So again, you have to think about, why is the data not available? Because to do a good study takes 40 years. By that time, we've all moved on,
Moved on eventually.
We're not regulated anymore. So those are the challenges. You need to work with what the data you have available and what you do know, and the complexity of it.
What I can add, if we talk about risk management, is also that is also linked to in which society you are working. It is to think of amateur use and professional use, and especially rodenticides. That's what we are doing. We are lowering. We can restrict, but that depends on your society. We can restrict the use to professionals and rodenticides. They can do the treatments because they are educated and they know how to behave for themselves, for general public, and for the environment. But that is not often always the case in all society, that you can say these group of people are professionals. They can handle more difficult products in a safe way compared to the ones you sell and can pay. But that's one route we are working with as well, and I will tell you later on. Interesting. Yeah, coming back to this, just a little bit to finalize. To me, it's easy to make a risk assessment or a decision or propose a decision. If my exposure is below the AUL, I say, okay, we cannot cross. That's my recommendation. It's the same, this is another example. It's a acute reference dose. It is the dose that you or a kid could eat during a day, say. It's linked to acute effects. What is incorporated in that is also toxicity to reproduction. That's a special case. We could say it's a long-term effect. However, if you are exposed, you are pregnant and you are exposed during a very narrow, you should say, window, when the fetus is developing, and when we come back to that, things might go wrong. So therefore also, if substances are toxic to reproduction, we establish an acute reference dose and calculate on diets whether that one is exceeded or not. I guess.
Sorry, how do you calculate this acute reference dose? It's worked out as a percentage, but what is it?
Now you are asking questions.
Okay, it's not.
You again. You go back to, you go back to this. Let's say it's it's organic phosphate. It's really toxic. You have a value here. I don't know whether you look perhaps into, it's enzyme activities and so on. You see it in animals, and you see it also an effect on the animals. So let's say you find this. So that is the acute reference dose. That is this dose. It's in parallel as an operator. You see?
Kind of, yeah, but it's a percentage. I'm not quite sure how it's. You're saying it should be less than 100%?
Yes. And that is a decision-making decision. It's a decision. Because if you put the dose, you say it's, let's say it's 10 microgram per kilo. Okay? That's your dose. You say that one is acceptable. That is the 100%, that dose. And then you check the food. You look at the vegetables, and then you take them one by one, or you look at the diet during a day and you add together. And you say, okay, for a person in South Africa, they have this type of diet, and they are exposed to that substance, and it goes over that reference value I got about 100%. If you go above that, you have a problem.
Just what Andrea was saying, we're still looking, this is from the hazardous substance, from the acute effect. We don't have too much data for a long-term effect. It's a bit too complicated.
But
There
you
is
got
some
the
data
idea.
behind
I've got
that,
that.
yeah.
And that is the same long term.
There is some, you'll find out how we're doing.
If we talk about risk to consumers now, we go to that part. And then we look at residues, and you said you just monitor the ones you export. But anyhow, let's say you're monitoring, you have some sampling methods. And I think as authorities, you ask for data when you are going to register that product for that use, or you will do in future. We do it. As I said, I go back, the company comes in and say, I would like to authorize my product for use in potatoes, apples, and salad. Those rates, and this pre-harvest interval. After this day, no more spraying, and you harvest on that day. So all this data is that. We do our risk assessment. The company is also submitting residue trials. They are measuring the residues in the crop according to that what we call good agriculture practice, what has been defined by the company. I support this use. So we have the residue data also, and then we calculate it. And either it's okay or it's not. And what could happen when you have too high residues? That is that in that case, it was higher dose rate used. That is one cause. Or you made more applications, you were treated more times. Too close to the stop between the last and the harvest. That is another reason. And of course, I mean, if you have a problem, that it's high toxic substance. So it could depend on different factors like that. And you take it into account when you do your assessment. You said about long-term effects, yes, but we are doing those. We calculate also ADI, acceptable daily intake during your lifetime. And then again, we have the data from the animals, and we follow the effects in the animals for their lifetime. And we say sometimes humans are a rat, or we are a pig, or we are a dog, and we work with those assessment factors.
Now just, is everyone clear about how that works when Lillian was saying that we use a rat or a dog or a rabbit or pig? Is everyone clear about that? So in other words, we're doing lab testing on animals in order to see what the effects will be. We try to use animals that are similar to humans, and then we get what's called animal data and we extrapolate it to humans. So does anyone know what, how much the human weighs that they extrapolate to?
75.
It's 80, yeah, it's about 80 kilograms. So the data is being extrapolated from animals, you have animal data, and you extrapolate it to an assumption that the person being exposed is a healthy European male, is generally what they're using, because the assumption in Europe is that the males are doing predominantly the spraying, and they weigh 80 kgs. So do most of our men weigh 80 kgs? Asking the men. Many weigh less.
And don't forget we have affirmative action, so the woman should also be in the field spray.
Well, they are.
They are. And the men in Europe are surprised.
Yes.
I tell you that. No, but Andrea, actually what has happened in Europe, it's coming from northern part of Europe, we say we are opposed to that 80K.
80 kg.
Yeah, we say it's 60 because we say exactly that. Also women's are, and that's true, women are also out in the fields driving the tractor, so, and that should be taken into account. One addition, when we talk about diets, acute reference dose, if you look into the documents and reports and so from us, you also see we calculate for a toddler, small little person, and also for a German girl in 8 years or something. So we also calculate the intake for children, and that's most relevant for acute reference dose. And often we find problem there. So it's not only adults.
Yeah.
I'm not the expert there either, but this is also how to calculate what is taken into account, and so there are lots of guidance documents also on the web. Yes.
And my question is to Andrea, when you're taking into account the self-represented intake, you're looking at somebody in Europe, because the daily intake for Europe and Africa is totally different. So, and you need to bring this to Africa. There's not have maybe a disparity there. Because, for example, in Europe you have maybe 3 meals per day. In Africa only once. And that's what is going on in the rural areas. So does that put into account what?
So the persons who would have to take that into account are the regulators. So the regulators receiving the risk assessment data from Europe would have to ask those questions. And that's my point about this contextual. So what's happening is we're often taking the data and we're just using it and applying it. We're not then taking it to the next layer and saying, okay, what is our context? And was it actually measured on children, or was it measured on healthy European males? And how does that fit our, what kind of food? It's also based on their own breadbasket, what are the food here?
Yeah, that's the point. But I'm just putting here, I mean, we have established now, we have harmonized our MRLs in Europe, and the ones who are exporting to our market knows very well about that, especially South Africa, they know very well. But we saw also, when doing this, we were, as you say, we were also comparing diets, for example, in Sweden to Greece, very different. They use a lot of olive oil, for example, we don't, not at all. And we eat much more potatoes and so on. So we started off with our national diets. And for national authorizations, I think we at least check it. But everything has been harmonized, and how we did it, I can't explain you, but it must be some kind of overall assessment. And now we have a list of this for a lot of crops. Also on the internet, that when you can go in and click what is the value. And I see you are really tired. Okay. I'm trying to finalize this and get to work.
But I think we need to just emphasize that point that you were making. So you need to think about what Lillian is saying in terms of the fact that she's talking about the European Union and how many people are working on pesticides. So how many people would be looking at the different, the bread baskets? How many people work on pesticide?
20.
That number?
If I say like this, I may, now I just guess, but it could be, if we, in some countries, still a few, but let's say in the big countries like Germany, UK, Netherlands, and also Sweden, 200 something.
Okay, so 200 people who are assessing the use of pesticides in their country. How many are there in Zimbabwe?
I mean, Zimbabwe, three people.
Or,
Sorry?
Doing the assessment on pesticide use, Ministry of Agriculture, how many do you think? It's not many, eh?
Mr. Goldberg.
There's only one department which does that, the pesticide registration.
And how many people are there?
Less than 5.
Less
Less than
yeah.
5,
Yeah.
okay, in South Africa?
no, less than
Less than 4? And in Lesotho? Lesotho doesn't have legislation. What other countries have we got? In Guyana, how many are you?
About 10.
About 10, okay.
No,
Malawi.
about 2.
2, okay, Zambia,
About 5.
at 5. Where am I? 3.
But may I add to that, Andrea?
Let's just get Samoa. Samoa?
Less than 10. Less than 10.
Less than 10. Okay, and in Kenya you've got, do you know?
Yeah, just in registration.
Yeah.
I think more than 10, maybe 12.
Kenya's pretty good, yeah, okay.
But add to that, I mean, I say we were 27 countries, I guessed. But when we started, there were some countries, for example, you have also some islands, and we have Luxembourg, always one person, Luxembourg, one person. And then you have UK and Germany, one person. So, but even though, look at Sweden, my colleagues, I'm in another unit now, but the ones dealing with these things, I do a rough estimate, 50 in Sweden. Remember, we are not doing all substances. We are doing some, and that work we are doing on behalf of colleagues in the other countries. And then we take over the work from UK and Spain, Italy, and we work together. And that's another message I give to you now. And I know FAO is really also very keen on that you realize you can't sit on your own in your country and 5 or perhaps a very, very good situation, 10 people, and do this type of job. You must cooperate. But you can cooperate at different levels. And that's why I'm again coming back and use work that has been carried out by others and adapt to your situation.
So that is the key point to build on, is to use what's being done in other countries. So use the risk assessment data, but adapt it. So then you have to have people who have the skills and the ability to ask the questions. They need to be able to understand risk assessment data, they need to be able to understand the toxicology data, how is it being extrapolated, what kind of diets are people eating, how are people exposed, are children who are bringing kids. So it's those kind of questions that your team of 3 or 2 or 5 need to be able to ask. That's where the challenge is. So it's not just accepting the data, but it's using it appropriately.
I'm trying now to finalize so you get to the break.
The break's at 10:30.
Is it? Yeah. So it's still 15 minutes.
But you can get them to stand up.
You want the microphone just to stand up and try to recover. No, but I must see because I thought that it took longer than I expected. Is it too technical? Too much technical? Yeah, I know.
This is nothing, Lillian. Gets very technical in course 2 and 3. You learn how to do the reference
No, but I
test.
know, I mean, to try to catch all these terms and so you can try to sort them. I know it's a bit too much. And that's, I think it's better that we discuss and we do things and you can read it on your own, and because you will come back to it. Yeah. So
Vincent.
Yes. How's it, man? My friend, I slept and I thought I was gonna wake up at 5 and do the assignment.
When you knocked off, I was thinking I was when I slept.
I thought I was gonna wake up at 5 and do the assignment, but you.
Okay, I should stand here.
It's there, I've moved
It's
there.
there.
Yeah. Those are the ways that one uses green value address.
Hello. Have I done with? No. Good morning. My brain is slow this morning.
That was awful. I can hear what you are saying, but
Now to reply, yeah.
that's the one. So when I'm in Malawi or something, I can hear when people are talking about me.
They cannot
or what
talk
they're
about you,
talking
yeah, you
about. I can hear that these people are saying. The problem is, I'll just say that you
Okay, let's
guys.
start again. Because we're going to break in 10 minutes. No, it's even shorter unless you want to discuss. But we need to answer her question. But she's not. We'll answer her question. I think, did we distribute that small guidance document?
No.
No.
So we just,
No, they can have it if I just take on this. I'm at the end of for this part. What we, as a first step,
take one and
to try to guide you and colleagues globally, we did this kind of guidance, and you will get it on paper. It's also on Bula, I think, and one convenient thing with that one, it is that if you put it, it's a PDF file, you put it on your computer, you can click on the links, and you get there if you have the internet connection. We will work with this document more tomorrow, and also today we will work a little bit together. What we are aiming for with that document is to guide you to some major websites, and I have my experience from Europe, so I can guide you to those websites and try to explain what you can find there. I cannot guide you to US EPA. Somebody else has to do that. And I think within the FAO system, they are working on that. So that when the FAO system is up working, you can find guidance also to other websites and reports and so on. So I will only talk about what is available in European system. What we also put there is to a simple explanation or we describe the processes, because what you need to know, and I will come back to that, you need to know what's the background from the reports you find, who is the owner of them, and who drafted it, and where does it come from. That we try to explain in that document. And at the end we put, I think, 2 examples. What type of information you can find and how to find it. Now, when you are doing such quite detailed guidance, you know the problems with links. All of a sudden we saw that the main link was changed. So then we updated this one, but you must also see it kind of it will become outdated unless we are able to update it fluently. But I think if you have started to use those websites and look into the reports and information, you find that you get quite quickly familiar, and then you don't need that guidance. Then you find your way anyhow. But if new people are coming in and if the websites and the links are outdated, it's probably not. But we try to do that. We started discussing also what we discussed here now. Could we also guide on how to use the information you find? But we stopped that because it's a second step. And we can't tell you how to use it. You must, at least we must discuss together some further guidance on how to use it in a region or in a country. So that is not guided here. It's only how to find information. And that is very much also linked to the process that has been ongoing in Europe. And I will explain you a little bit later, but I think we need really a break now.
Okay, did you want the second slide for this?
It's links, I think, so it's... We can have
I've got it.
Yeah. It's also, okay, it was that one. You can find a lot of MRLs on that database. And that is, you can see also what could be relevant for you in Porter EU. If you don't find an MRL, because that substance is not authorized, you don't establish MRL, but you can ask for it.
So you're saying that, let's say for argument's sake, a herbicide was banned in Europe 10 years ago.
Yes.
If we're still using it here, you're not going to test it for a pig.
You are still using it here.
Yes.
Mhm.
And you're not testing for a pig, or you say you've only included the chemicals that you are allowed to use. Surely
Yes.
you still have some.
It might be, it was used 10 years ago, as you say.
Yes.
But it was taken from the market either by industry or by authorities. It could be so, as I said, and that I will also talk about later on, we had a process. We reviewed everything during, now it's almost 15 years. So it's up again for review. And during that process, active substances were off for different reasons. And if it's not on the market, to be on the market, we need this data. So if it's not on the market, you don't establish it. But you could, as I, now it's not our authority working with this, but as I understand, if we import it from your country, you can ask for an MRL to be sent to your gap, to the use in your country, or South Africa, or in Zimbabwe.
I'm just why, sorry, when you said that, I know there are chemicals that we used in Zimbabwe, say 10 years ago,
Yeah.
that are still in the soil, that are still coming out in the produce that we're sending to Europe, and we're having it decline. You know, so even though we may not be using the chemical either any longer, they actually are still above the MRLs for Europe, and the crop is then banned. I'm not sorry, the crop is then destroyed.
put on the local market.
Or send back home.
No, but you don't, oh yeah. But yeah,
But the point, oh, go ahead.
and then you address another thing, coming to policy and so on. You know, decision-making criteria, caused by these things. And I told you, we find still DDT. I have DDT in my body, and we find it in the fish everywhere. It's a similar problem. At least we try for future then to not add new substances having those properties. We talk about PBT substance, persistent bioaccumulating and process. We skip the risk assessment. We say it's enough, they fulfill these criteria, we don't authorize them. For that reason, for example, as you just described. Yeah. Too late.
Yeah.
It's already there. Yeah, it's a headache. I mean.
So the other point that you raised, that Dennis raised, is the issue that, you know, we're talking about using the data from Europe or from the US, from other countries. But in many countries, they're no longer registering the product. So I know you're going to go into that a little bit more later on when we look at this, the database. But basically, you know, most of us have, until recently, were using Eldecarb, and Eldecarb has been banned for a long time. So what happened there was it was too expensive for the company to do re-registration and produce new data. So you also then need to ask this question, what is the date of the data that you're using? So if you're looking at data, is there a date on it? When was it last done? Was it done 10 years ago? Was it done 20 years ago? So those are other questions that you need to ask. I'll come to you just now. But so what I want to say to you is that what we're trying to teach you is how to critically appraise and the questions you need to ask for your context within which you are regulating or using these chemicals. And that's the kind of thing that I would like to see you putting in your books. Or did I just get it? There. So I'd like to see you have a section here where you're reminding yourselves of the types of questions that you should be asking. Because you're going to get lots and lots of things, and we're talking in detail now about risk assessment, and we're going to move on to something else later on. So that's the kind of thing you could be putting in your journals, is what are some of the key questions that you have to remember to ask. Next week we're going to do biostatistics. We're going to learn to look at data that's being used for these risk assessments and what kind of critical questions you have to ask methodologically, how the data was put together. So there's a lot of things to remember. To try and document it if you can. Vincent?
Oh, sorry. My question was, once the product, like it has been rejected from the European, you are saying it goes back to the local market.
It can be used on the local market often.
Are there no regulation of destroying those products?
Will you answer that question? Have you got a regulation in Zimbabwe about destroying?
Yes. If something has been,
Have you asked Monica, does that happen does the Department of Agriculture destroy crops if they don't meet the residue limits for export?
I think it depends.
But you see, we've got no maximum residue levels for our local products. Because if we did use those criteria in Zimbabwe, there's a lot of products that wouldn't be allowed on the market.
So we have in South Africa, we have maximum residue limits. The problem is that we're not testing the local market. So we've got the limits, we have the regulation,
We don't have the regulation.
but we don't test. So it doesn't, you know, we had an incident, okay, it was a while ago now, we had an incident with mangoes. They were rejected for the export market. And then somebody decided to test mangoes on the local market and discovered they were way above the maximum residue limit. But we don't test, that's the problem.
also the regulations are there,
Yes.
but there's
In
no
South
testing.
Africa, yeah,
Yeah, even in Zimbabwe, the regulations are there, but there's no testing.
yeah.
Yeah.
So you wouldn't know if you know, a maize crop has too high a residue limit that it can't be exported, or oranges or apples or wine or whatever. You actually don't know because it's not tested.
Even what we import from other countries, especially if we import maize, just get the maize in the country and give it to people. It's not tested for its benefit.
Yeah.
What usually happens, what is destroyed is what is not already reaches Europe. So when it goes, it reaches Europe and they test and they find the MRL is high, they'll destroy it there at your cost. But before it leaves here and they find that it has high MRL, they'll stop it from going to Europe and take it to the market.
Yes, that's usually the way it works, yeah.
And
Rowena?
the other question is, when you are importing, when you are exporting, like from Europe to Africa, do you also do those testing so that if it's below MRR, do you destroy it or just send it?
Yeah. I think no, but I think we don't distinguish. I mean, there is a monitoring system ongoing. Whatsoever is imported or is kept, it's exported, imported within the European countries, or if it goes out. I mean, there is a control system there, where you pick by chance, or you can also direct to certain crops if there have been problems. We have had, as I said, also problems internally. But if I don't expect that we separate. I mean, let's say that Spain is producing grapes, or you don't import grapes, but we say something else. And you test. We have a system that is also, there is a system of sampling crops and checking the residues in general in Europe. There is a special agency that is steering the whole thing, and they go around to countries and check the monitoring reports, and that is it's also put on internet as reports, the finding. And I can't think of that you are separating. This goes to Zimbabwe and this goes to Sweden. It's the same treatment.
So Kuena has a question, and then Ramonda has a question.
Yes, just a question from the point of view of someone who's not an expert in pesticides. Why would data from risk assessment done 10 years ago not be relevant to use now? What is
A good
Is-
question.
Very good question.
Yeah. It is because if we go back, I look at my own country, and I think that was the situation in many countries. You applied, you authorized a use of a product, and then it was authorized. You didn't look into it, unless you saw a problem somewhere. DDT, you saw that it's a problem here, you must take it from the market, and so on. That was the situation, and I guess it could be the situation also now in your countries. You authorize it, full stop, unless you see a problem, then you must act. Okay, science is developing. We can take, for example, the endocrine disrupting thing. It didn't exist 20 years ago. We didn't think of it, more or less. It was starting to be discussed. So what has been agreed was, we started in '86, I think the government said, you must start review all pesticides on the market in Sweden. And that started also in the European Union. You must review. You must call in data according to updated data, according to data requirements we have agreed now. And then I say that work was done in cooperation with different countries within OECD. So the company must come then with an updated dossier with new data to cover all these aspects we are talking about. That's the reason. And what did happen then? I will tell you also later. It cost a lot of money, of course, to do all this testing. Yeah. So a lot of substances just disappeared because the company thought, I don't know, they were calculating, it isn't worth it. We have better alternatives, more effective and so on. It's a good question. So that, and that's why you also sometimes in the database, you just say not approved. And there is no data, no report, nothing, because it wasn't submitted any data, so it just went off the market. But the reason why it's risk related, if you know nothing, but you know it's a biological active chemical, then you start to worry, and then you say, please give me an updated dossier. And when we got that, we saw, for example, the whole area of toxicity to reproduction grow, new studies, and then linked to that was also the issue of endocrine disrupting substances. So that is the background. And now if you look in the OECD, FAO Code of Conduct, you know, there, you looked a little bit yesterday, there are lots of recommendations to industry, to authorities and so on. And one recommendation is clear, they say you should do reviews. And that is also, we will talk about highly hazardous pesticides later on. It's good if you do kind of a program. And because you can't look at everything in one go, you must do kind of a program so everybody could adapt and give industry the chance also to update their dossier or buy in data. It's also one way. And you do a program, and especially if you are only 5 people or so in quality, and you can't cope with too many. And that was what we did together in European Union. We started off with 90 substances. And then we added and added. And it was a program going for since 95 until now.
So we need to take a break, but just to come back to that, if you're clear what Lillian said, basically in law there should be a re-registration time period, about 5 years.
No,
No?
it's too short.
Well, it depends.
We-
Some
yeah.
have 5, some have 10. But So 5 to 10 years, and why? It's because of the research changes and the research data. We often don't do re-registration in our countries. I don't know about Zimbabwe, but in South Africa, where I think we struggle a bit with re-registration law because it's costly and time consuming. But the data changes. So there's research coming out all the time, environmental research, health research, either being generated by the industry or being generated by independent scientists, and that needs to be taken into account. So risk assessment data isn't just necessarily from the research that industry is doing, it's also the research from academics like what we're doing. I mean, we've impacted how Aldecarb was registered in this country because of the research we were doing. So it's, you know, you need to take that then into account. So let's just quickly answer, can you answer that very quickly, Ramondas, or do you want to come back to her question after the break? Want to come back to it after the break?
It's the one on MRLs.
Yes.
What are the accepted? I will come back to that
Okay.
because these are really related to the youths supported by industry. I call the GAP, Good Agriculture Practice.
Okay.
Those rates.
So we'll come back, Ramanda, we'll come back to your questions. We're going to have a break for tea. Just before we break, there are 3 things. So one, I want to formally introduce you to Halima Parker, who is the administrator for this program. And just so that you're very clear that if there's anything to do with content and academic issues, you come to me. And if there's anything to do with administrative issues, you go to Halima. And if there's any issues with VULA, we have a VULA expert. So Nancy's just been assisting. She's actually working on a separate program. So you need to contact Halima if you have any issues. The other thing is I have some documents that have been left over from the years before. but I don't have enough copies for everyone. So I'm going to be rewarding people for different things and giving you copies. If you don't want it, then just put it back in the pile and we'll redistribute it to someone. Like you might not want any of them because a lot of them are FAO documents. So I'm going to reward the 4 people who asked questions.
More easy.
And hopefully it'll encourage the others to ask questions. And then there's a student support and services handbook for you. There are PDF copies, but if you would like a hard copy, please take one.
Get them from the
And Khalima's going to take you for tea. She's going to show you where our tea room is on level 3, where you can have free tea and some biscuits. And then you need to be back, let's say 11:15. Let's give you half an hour. I think you need that. Those who haven't collected the books need to collect the books with Halima. Okay, I will lock the room so you can leave things here, and I'll see you back at 11:15. Rolanda will turn you off for the moment, and we'll see you back at 11:15.
Go for tea.